There you go. Okay, so for chapter 10, we're going to move on to hypothesis testing. So 10 and 11 really focus on hypothesis testing, which is like the other side of that purple sheet that I gave you a couple weeks ago. So we've done confidence intervals. That's what was chapter 9. Chapter 10 starts hypothesis testing. So the write-ups get longer. We're not actually going to do a full write-up until like Friday, but this is kind of your beginning part. We're just going to look at what gets added today. So a hypothesis, you've done these in like science at some point, I'm sure, is a statement about a population characteristic. So that's usually your hypothesis. In a hypothesis test, this is what we're going to be doing the rest of the year. We make an assumption and then attempt to show that the assumption leads to a contradiction, showing the assumption is wrong. So there's two types of hypotheses. So there's, two types. The first type is the null hypothesis. And we write the null hypothesis as H sub 0. I sometimes call it the hoe. It's what I do. So this is a statement or a claim about a population characteristic that's initially assumed to be true. You always assume your null hypothesis is true. Okay, this is your starting point. This is what we're going to be looking at. Then you have the alternate hypothesis. That's noted H sub A, or the ha. So you got a ho and a ha. This is a statement that specifies that the population value is either different in some way from the given null hypothesis. So usually the alternate is either greater than, less than, or not equal to, if we're looking at some value. So we always have two of them in a hypothesis test. We assume one's true. We're trying to contradict it by proving the other one's true. So what we try to do is we reject the null hypothesis, which means we then accept the alternate. So in a hypothesis test, we assume the null hypothesis is true. We test it using data and all our stuff from the first semester and draw one of the following conclusions. We either reject the null hypothesis. This is the equivalent of saying the ha or the alternate is true. Or we fail to reject the null hypothesis. So this says we fail to show a statistically significant deviation from the claim of the null hypothesis. We don't necessarily say the null hypothesis is true. We either reject or fail to reject. Okay, because you're assuming it's true, so you don't ever really prove it is or isn't. Think about a trial. This is kind of like the one I always revert back to. If you think about like a judicial trial, your null hypothesis is that the defendant is innocent. Okay, that's what you're assuming is true, right? They always say innocent until proven guilty. So your null hypothesis is that the defendant is innocent. Then people present evidence. In our class, it's like data. We do some math, that kind of stuff. In a trial, people go up, they present evidence. You're trying to prove guilt beyond a reasonable doubt. If you prove guilt, the defendant is guilty. That will be rejecting the null hypothesis. If you cannot prove the guilty, then the defendant, we say, is not guilty. We do not accept the null hypothesis. Just because you say somebody's not guilty doesn't mean somebody's innocent. Does that make sense? Think of OJ. He was not guilty, but nobody ever really proved he was innocent. People still think he did the crimes. Okay? So we don't ever really accept the null hypothesis. We either reject or we fail to reject. So your conclusion statement in your write-up is going to either say one of those two things. Today, we're really just going to focus on writing these two hypotheses. So on the back. So the null hypothesis has to contain an equal sign. Usually it's some hypothesized value. In Chapter 11, we're going to look at two different populations. So we would say like men and women make the same amount of money. In Chapter 10, it's usually some hypothesized value. Like the average on your test is going to equal 70%. Something like that. So the alternate is what you're attempting to show to be true. So your null hypothesis will always be mu equals or p equals some hypothesized value. There's a reason why in your condition 4 that you define mu or p. That's because in your null hypothesis you use the letter mu or p. The hypothesized value is always determined by the problem. Then the alternate, you have 3 options, depending on what the problem is asking. You can either have not equal, less than, or greater than. I said them and I wrote them the opposite. So either not equal to, greater than, or less than. We don't do greater than or equal to or less than or equal to because you're assuming it's equal to begin with. So you have 1 thing for the null, 3 for the alternate. This is always given in the context of the problem. The problem will tell you which one of these you're using. So you don't have to ever really figure it out. So just words of caution. When you set up a hypothesis test, here are your 2 options. Either you have strong support for the alternate hypothesis, either one of these, or there's not sufficient evidence to refute the claim, so you're just stuck with it is equal to. So if they can't prove beyond a reasonable doubt that somebody is guilty, then the person is not guilty. You just, because you always assume they're innocent, so they just let them go. Okay. So those are your 2 options. So today again is just focusing on writing the 2 ho and the ha. So, first one, you would like to determine if the diameters of ball bearings you produce have a mean of 6.5 centimeters. So a lot of times in engineering, certain machines they'll give them a certain leeway. So you're trying to determine if the diameters you produce have a mean of 6.5 centimeters. So your null hypothesis is going to be that mu equals 6.5 centimeters. And you know it's a mean because you're looking at some sort of measurement, not a proportion. The alternate here, do you care if the ball bearings are greater than or less than 6.5? Or do you care if they're either one? What do you guys think? It's not saying they have to be greater than or less than. So if it's kind of a neither situation, go with not equal. You're trying to prove that it's not 6.5 centimeters. Again, remember your alternate is your competing claim. You're assuming they're 6.5 centimeters when they come out. You're trying to show they're not. Either greater than or less than. So look at number 2. The students entering into the math program used to have a mean SAT score of 525. Are the current students doing poorer as measured as an SAT quantitative score? So your null hypothesis is that the mean is 525. The null is real easy to figure out because it's always equal. The alternate, you doing poorer would be what? Greater than, less than, or not equal to? Less than. So you're trying to prove they're doing less than 525. You don't necessarily have to have units when it comes to these. Number 3, do the 16-ounce cans of peaches canned and sold by Del Monte meet the claim on the label? So meet the claim on the label. That's what we got to figure out. So again, you're assuming it's 16 ounces. For our alternate, we got to think about who is asking this question. Do they meet the claim on the label? Would you care if you got more than 16 ounces of peaches? No, right? It'd be bonus, right? So you're trying to show that there's less than 16 ounces. Most of the time, once we get to the actual full write-ups, like on Friday, it'll be a little bit more obvious. So sometimes you got to think about when you're trying to figure out your alternate, think about who is asking the question. Here, if it was a consumer, you'd be looking for less than. If it was like the people at selling the peaches, they would probably want to know greater than. Is the proportion of defective parts produced by a manufacturing process more than 5%? So now look, we're looking at a proportion. So this would be P is equal to 0.05. Is it more than 5%? So P is greater than 0.05. We're going to start with hypothesis testing for proportions first, and then we'll go to means, just like we did in Chapter 9. 5 actually looks like what we're going to do in Chapter 11. Do 2 brands of light bulbs have the same mean lifetime? So Chapter 11 is all about comparing 2 things. So it'd be like comparing first hour, second hour, men, women. So usually what we do is we do like a mu1 and a mu2, or like mu-m, mu-f, men and women. So here, do they have the same lifetime? So you would say like mu1, you're assuming they equal. If you don't care about which one's greater, then you just put not equal. So you're trying to show that they are not the same, that one brand is either greater than or equal to the other. Do the parts of 2 different milling machines have the same variability in diameters? Now, honestly, we don't do this very often. Variability, do you guys remember what symbol that would be? Yeah, sigma. So this would be like sigma 1 equals sigma 2. If we're trying to prove they have the same, then the alternate is that they're not the same. You can put a star here. This is not very often done. Usually we just look at 1 through 5. The 6 is just kind of help you today. So, super short notes. Homework. I sent you the book, page 525. You should be able to finish before you leave.